Hello people, welcome to Let's Get to the Marks. This is a new series of chemistry videos that I'm releasing, hopefully one a day in preparation for the 2025 exams, and I'll be going through the whole of the chemistry course, hopefully through a series of videos which will supplement your exam past paper practice on the Physics and Maths Tutor website or on the AQA website or OCR website, whatever chemistry you're doing. And this is a A-level chemistry set of questions on relative mass. So look at these questions. We've got question 1. Copper, Cu, exists in two main isotopic forms, copper 63 and copper 65. A. Calculate the relative atomic mass of copper using the information from the mass spectrum, and it's worth 2 marks. B. Explain why the relative atomic mass of copper is not a whole number. That's worth 2 marks. Question 2. The percentage makeup of naturally occurring potassium is 93.11% 39K, or 0.12% potassium 40 and 6.77% potassium 41. What method is used to determine the mass and abundance of each isotope? 1 mark. Use the information given to determine the relative atomic mass of potassium, and that's worth 2 marks. So grab a scrap bit of paper and have a go. Pause the video. You'll need to pause it so it doesn't go on to the answers, and have a go. I'd give yourself about 7 minutes to try and do all of this to make sure that you're on time, and then unpause the video and watch me go through the answers. Let's go. Okay, the answer for A, calculate the relative atomic mass of copper using the information from the mass spectrum. First, we want to highlight the relative atomic mass of each isotope, so 63 and 65. We need to individually times them by their abundance, so 63 times 120.8 and 54 times 65, and that's going to give us 11,120.4. We then need to divide that by the total abundance, which is 174.8. I got that by doing 120.8 plus 54, and then we get our final answer of 63.6. So that is the RAM of copper based on the data from this spectrum. Let's move on to the next question. Explain why the relative atomic mass of copper is not a whole number. So why is it that the relative atomic mass of copper is not a whole number? Well, copper is a mixture of 2 different isotopes with 2 different abundances in this situation, one with 63 and 165. And the RAM is the weighted average mass of these 2 different isotopes, and they just so happen in this case not to equal a whole number. So it's a mixture of 2 different isotopes, and the weighted average mass is not equal to a whole number. Right, question 2. What method is used to determine the mass and abundance of each isotope? Well, that's mass spectrometry. You can also say time of flight mass spectrometry. And for the final question, we're looking at the RAM of potassium based on the data above here. So once again, take the abundance of each isotope, multiply it by the mass, add it together, and then divide by the total abundance. In this case, the total abundance is 100. Once again, this was for 2 marks, so you get 1 mark for coming up with 3,913.66 and a final mark for coming out with the correctly rounded answer of 39.14. Okay, make sure you hit the like and help out the channel, guys. I really appreciate the support. So anyway, don't forget, let's get to the marks.
You're still here? It's over.